In this video, assuming that the GCD of A and B equals 1, we want to show that the GCD of 2a plus b and a plus 2b is either 1 or 3. Before we get into it, just want to remind you that if you just love watching videos like this where I prove theorems after theorems, please subscribe to my channel, leave a comment, please hit the like button. Let's get right into this video. Let D equal the GCD of 2a plus b and a plus 2b. Then D divides 2a plus b and D divides a plus 2b. After all, D is a common divisor of those two numbers. In fact, it's the greatest one, but nonetheless it is a common divisor. Well, that implies that D divides the sum. When you add those, you get 3a plus 3b, which means D divides 3 times a plus b. Okay, now D also divides the difference, 2a plus b or minus a plus 2b. That is, D divides a minus b, which for the record implies D divides any multiple of a minus b. So we have D divides this and D divides that. So D divides 3a plus 3b and D divides 3a minus 3b. Then D divides the sum. When you add these, you get 6a. And D divides the difference. This minus that is 6b. Okay. D divides 6b. Now, can D go into A? Yes, it can. But it won't go into B. Okay, they don't have any, A and B don't have common divisors. Okay, since the GCD of A and B is 1, that implies D must go into the 6. Well, this implies that D is less than or equal to 6, which implies D equals 1, 2, 3, or 6. I want to eliminate 2 and 6 for obvious reasons, because D is only supposed to divide 1 or 3. Okay. Now, what would it mean for D to be 2? Now remember, D is equal to the GCD of 2a plus b and a plus 2b. Okay. If D is equal to 2, D must divide 2a plus b and D must divide a plus 2b. Well, clearly D divides this. I meant to put 2 because D, we're assuming D is 2. Well, D2 definitely goes into this. This implies that 2 divides b. 2 definitely goes into 2b. The only way 2 is going into the sum is if 2 divides a. But that's a contradiction. That would imply that the GCD of A and B is at least 2. But it isn't. Okay, so D is not 2. So let me come up here and cross off 2. Now, if D is equal to 6, that would imply that 6 divides 2a plus b, and 6 divides a plus 2b. But 6 only goes into even numbers. This number is even. B can't be odd, because an even plus an odd is not even. 6 only goes into even numbers. So this here implies that B is even. 6 only goes into even numbers. Regardless of what B is, 2B is even. In theory, B can be odd, although we already said it's even. B can be odd, but A has to be even, because 2B, regardless of the parity of B, 2B is even. So then A has to be even. This implies that A is even. But this is a contradiction, since if A and B are both even, then the GCD of A and B can't be 1. It would have to be at least 2. So D cannot be 6. Hence, D can be 1, 2, 3, or 6. D can be 1 or 3. But that is what we wanted to show. Pretty nice proof, huh? Okay, once again, if you like videos like this, click the subscribe button, like my video. See you guys in the next video. Watch and learn.